Let's talk about the standard long division algorithm. First, I want you to gather up some objects you can use as base 10 manipulatives, then build the number 42 with your manipulatives, separate 42 into 3 equal groups, then check back in. One way to divide 42 into 3 equal groups is to start with the tens, put 1 10 in each group. Then I'll need to trade 1 10 for 10 ones, which gives me a total of 12 ones. Now I'll distribute these to the 3 groups. And I end up with a total of 14 in each group. Guess what? We just modeled the standard long division algorithm. We used the partitioning, or how many in each group perspective of division. We started with 42 total units. We had 3 equal groups, and we figured out how many units in each group, or how many units in one group. We're going to use this model and this perspective of division to go step by step and try to understand why the long division algorithm makes sense. So let's get started. So we start by saying 42 divided by 3. The first thing that we have to recognize is that this algorithm is based on our base 10 place value system, so it's important to line things up. Here we had our tens and our ones, and usually when we start the algorithm we say 3 goes into 4 one time, and we write a 1 down. So what does this correspond with in our model? This corresponds with 1 10 in each of our groups. Then we say, then we multiply the 3 times the 1. That relates to the 3 total tens that we've used up. Then we subtract, because we are taking away 3 tens from the total, and we end up with 1. That 1 represents the 1 10 that we were unable to distribute. All right, let's move on to our next step. Okay, so then what we say is bring down the 2. Bring down the 2. Well, the 2 is in the ones place, so when we bring down the 2, that signifies let's start working with our ones. We don't usually do this in the algorithm, but we could cross this out and make it 12 ones. So this corresponds to, in our model, when we bring down the 2, that means we're switching to ones, and that's when we switched out our 1 rod, our 1 10, into 10 ones. So this 12 signifies that we're now working with 12 ones. All right, then we say 3 goes into 12 4 times. So what's happening here? This corresponds to where we took our 12 ones and we put 4 in each group. So here's the 4 in each group. The 4 up here in the quotient is 4 ones in each group. Then we would multiply, and we'd say 3 times 4 is 12. Well, that's the total ones that we used up. So 3 times 4, that's 3 groups of 4. That's our 12, 3 groups of 4. Then we subtract, because we took away 12 ones from our total. We took away 12 ones from our total, and we're left with 0, and that matches our model where we have no ones left over here. So then we're ready to have our answer. 42 total units divided by 3 groups equals 14 units in each group. So with this algorithm, place value is key. It's really important that we line up our tens with our tens, our ones with our ones, and we can interpret that to mean the number of tens in each group, the number of ones in each group. This would work if we had hundreds. This would work if we had tenths. We could keep distributing into our equal groups.